Thank you, Dr. Sir. Okay, good afternoon, all of you. So today we are going to see, we are going to start our unit number 5. Okay, and in this unit number 5, uh, as the name indicates that
Hello.
here we are going to see the.
Hello.
Hello,
Excuse
sir.
me, sir. Ah,
Yes, sir. Yes, sir.
area calling. Ah,
Yes, yes.
I am also
Let's
having my
start it. No
lecture.
problem. Okay, okay. You can leave this meeting. No problem, sir. Thank you.
Okay.
Okay, thank you. Okay, so I was talking about the this laser beam machining process. Okay, as we know that the classification of thermoelectric energy based non-conventional machining process. Okay, so in that thermoelectric, the electrical energy, okay, as per our syllabus, third unit was the electric energy based non-conventional machining process, and that we have seen that EDM and wire cut EDM. Now the remaining part of this thermoelectric NCM processes that we are going to see in this unit number 2. Okay, that means the thermal as per the syllabus, thermal energy based non-conventional machining processes we are going to see. Okay, so in that first we are going to as per syllabus, four processes are there in this topic. That is laser beam machining, then electron beam machining, then that plasma arc machining, ion beam machining. Okay, so today we'll start the laser beam machining. Okay, I will share my screen. Okay, okay. Whether my screen is visible at your end, Purutvi, will you please reply? Purutvi or Ashantanu, anybody? Whether my screen is visible
Yes, sir,
at your end?
visible.
Okay, okay.
Yes,
Thank you.
sir.
So I welcome you all for this lecture on laser beam machining. In short, it is called or it is abbreviated as LBM. Okay, laser beam machining. Okay, and today's this lecture, uh, I'm going to talk about first. I will give the introduction to the laser beam machining process. Then we are going to see the what is how the laser will be produced and the types of the laser. Okay, then what are the elements or the laser beam machining system that we will see. Then at last we'll go for the that process characteristics and its application. Okay, so let us start with the this first one, that is intro the laser beam machining process. Now I am going to give you at starting only I am going to give you a very interesting experiment that you also might have done when you were a child. Okay, you as I have shown the diagram here, you can see the first diagram, this one. Um, okay, so you can see as during our childhood we have experienced with this. Uh, I will say that you take a one lens, okay, and with the help of the lens, you can see here we have the lens, and with the help of this lens, we concentrate the sun rays on a piece of paper. We concentrate the sun rays, okay, on this piece of paper, and especially when the sun is bright. Okay, that time we will get the high heat. Okay, and that sun rays we are trying to concentrate on the small piece of paper through that lens. Okay, and you will find that that time when there is experiment also, after some time that piece of the paper start burning. Okay, so the question that time we are saying just it is magic, but what is this going on? That what the phenomena behind is that? Okay, that we don't know that time. Okay, so actually the phenomena behind that experiment is that you are utilizing the sun rays, okay, which are concentrated at a small point, and intensity at that particular point is so high that is that due to that only it start burning the piece of piece of paper. Once again I repeating that how that piece of paper is going to start burn, okay, due to that sun rays. Okay, because with the help of that lens, we are utilizing the sun rays, okay, which are concentrated at that small point, and heat intensity of that sun rays at that particular piece of paper or at that point is very high, and due to that, it start burning that piece of paper. Okay, and then again, once again, the question arises that can we make this constructive phenomena or constructive use of this phenomena in general and in manufacturing in particular. Okay, okay. Whether another question arises that whether we can use this phenomena for the any constructive purposes or in manufacturing sector. So now the exactly on the similar thought, a very important manufacturing process is introduced, and that name is there, or we know that it is known as laser beam machining. Okay, so due to this phenomena, laser beam machining is introduced. Okay, or that laser beam machining process has been developed. Okay, so here you can see, here you can see in this another diagram, you have the laser gun. Okay, with the help of which laser is produced. We have the laser gun. You can see we have laser gun, and with the help of this laser gun, laser beam is produced, and that laser beam is focused at a very small point, having a very small diameter, and that focused beam has so high intensity that you can burn or melt. Due to that only you can burn or you can melt any metal known to us. Okay, with the help of high intensity that mm, laser beam, you can burn or melt any metal which is known to us. Okay, even diamond can be melted by this particular process. Okay, so this is very important process, and it has been used for this process. It has been used for cutting or drilling a hole in the diamond, as you can see in this figure. I have taken the one workpiece. Okay, this is a we have the lens. Okay, you can see, and this is that is called focus lens, and this is a laser beam. Okay, so with help of this laser beam machine, we can drill a hole on the diamond workpiece. Okay, again, you can see in this diagram also we have the workpiece, and here is the concentrated light. Okay, here is a concentrated light at a particular at that particular point, which is uh, on which that concentrated light is utilized for melting and or evaporation purpose. Okay, so this tell you in very brief that working principle of laser beam machining is that you are utilizing heat produced by the laser beam. Correct. We are utilizing heat, which is heat produced by the laser beam, and due to that heat is utilized for melting or melting and vaporization of the workpiece. Okay, we are utilizing heat energy. Okay, we are utilizing heat which is produced by laser beam, and this heat is utilized for melting or melting and vaporization of the workpiece. Okay, so please remember this my statement. Here also, unlike EDM, here also we are utilizing the heat energy, and that heat energy is utilized for the melting and melting or melting and vaporization. Okay, that from due to the melting and vaporization of your work portion, the metal will be removed. Correct. Okay. Now, before going to the that uh, another point of this laser beam machining, uh, we should know the how that laser is produced. Okay, so production of laser. This is okay. So the question arises that how to produce a laser. Correct. The general question is that how to produce a laser. So hypothesis as per the hypothesis of Einstein. Okay, I will tell you. that Einstein he proposed that it is possible to use light energy to stimulate electron that would emit light of the same characteristic. Okay, hypothesis of Einstein tells is that under appropriate condition, light energy of a particular frequency can be used to stimulate electrons in an atom to emit additional light when exactly same characteristic as the original simulating light source has. Okay, okay. So he proposed that it is possible to use light energy to stimulate electrons that would emit light of same characteristic. Okay, and this particular Einstein hypothesis had been used to produce this laser. Okay, now consider in that you can see in the slide also I have shown the diagram. So consider an atom that is brought to high level energy, high energy level, that's E2 from energy level E1. Okay, suppose atom that is brought to high energy level E2 from energy level E1 by outside energy source. Okay, so your atom is brought at high energy level up at E2 from E1. Okay, by outside energy source. Now this outside energy source can be light, okay, it can be heat, it can be electricity, or some other appropriate outside energy source which will stimulate the atoms in the lasing material from your energy level E1 to the energy level E2. Okay, so this atom is then allowed to decay back to or retain back to your ground state level, state energy level. Okay, that is from from your high energy level E2 to your low energy level E1. Okay, so as a result of this decaying back, if proton is released by that metal, then this proton is nothing but the your light. Okay, then this whatever the proton is, whatever the proton is released, so that will be the your image. Okay, then now this what are the protons are there? No, that protons is proton is released no by that metal. Okay, so that proton is nothing but the light. So this proton contacts other atoms. Okay, in the your lasing medium, and this atom will also decaying back and release the another proton. That means atoms also will go first to your that new atom will will go first to E2 level, and from that E2 level it will decay back to your E1 level, and it will release another photon. And this leads to chain reaction that continues, and a stimulation emission of a photon keeps taking place. And due to that, as a result of this, you will have a large amount of photons in the lazy medium, and this sequence of triggering clone protons from stimulated atoms or molecules is named as, or it is known as stimulated emission. It is known as stimulation emission. Okay, got it. Then whatever this energy source is used so far that what are the energy source used now is usually so powerful, okay, that most of the atoms of the lithium material are at high energy level, and it will release of the protons. Okay, that keeps going on. Correct. So the energy level is usually so powerful, and that most of the atoms of lithium material are that are at high level, high level of energy. So that is E2 level, and that will decaying back, and and this process keeps going on. And as you can see in this slide also, the same thing is uh, shown in this figure. Okay, same thing is when it is figure how this transition by the transition by absorption and the quantum metal emission, okay, between your two given levels. Okay, the same thing is shown here in this schematic. Okay, here is the absorption of the energy. Okay, you can see absorption of energy, and then from this Q level, okay, Q level, it moves to the P level, and when it decay back to the Q level, it will release the photon. So this is a transition by absorption and spontaneous emission between two given level of an atom, that is from P level to Q level. Okay, so same thing. What I was saying from energy level E1 to E2, or here it is shown from energy level E1 to E3 also. You can see in this diagram. So they, due to that decaying back to the energy level E0, that is here in the place of uh, E1, here E0 is shown on this one. So here E0. So it's going to E3 and then back to the E0. So it will due to that time it will reach the photon. Okay. Now that is about the how the laser is produced. Now for actual production of laser, you need what is known as feedback mechanism. Actually, for actual production of laser, we need a feedback mechanism. Okay, that will. Now, you have, as I have shown in the diagram also, you have the lazy material or the lazy medium as shown over here. Okay, okay. I was talking about the feedback mechanism. Okay, you as you know that you have the lazy material or the lazy medium as shown over in this slide. As well. So this can be a solid that laser lasing medium or laser that material. Okay, it can be solid or the gas mixture. Okay, as we will discuss about that also in later part. And there are two mirrors are used. Okay, there are two mirrors are used. Okay, one is the your left side and one is the right side. And for simulating the atoms of the living material, you have the energy source. Okay, so this can be that energy source can be the electricity, heat, or light, or whatever it is. Okay, but it has to be have the some appropriate energy source. Okay. Now, when uh, the protons are moving in the laser medium, no, then they go out and the material. Okay, here as you can see, the mirrors are used. Okay, when that your protons will strike to the mirror, then one is the that mirror is the fully reflecting metal, and another is normally partially reflecting metal is used. Now, what will happen from fully reflecting metal? Proton will again go back to the releasing metal, and if it is right side, then it is a partial. Then that right side means that your partially reflecting metal is used at the mirror. Then part of laser, part of that proton may go out, and that will from what is known laser. Okay, so we will discuss it a little later also. Okay, so I was talking about the that feedback mechanism. So what happens in feedback mechanism? So actually that it captures the and redirect the a few coherent protons back into the active medium, that is the lasing medium, and it simulates that emission of some more protons. Okay, that I have already explained as a chain reaction. Okay, and also it permits a small percent of coherent proton to exit as a laser light, as I have mentioned that on the right side. Right. Okay, suppose it is 90% reflecting in the slide you can see. Okay, so that will um, that laser beam it has 95% reflecting, and then from 50% whatever this part of laser, that part of laser beam will exciting or coming out of that it, okay, so that will be utilized for various purposes. Okay, and on the reflected, no, it is known as the laser light. Okay, and the laser as we know that full name, light amplification, full form of that laser, light amplification by stimulated emission of radiation. Okay, that forms what is we in day-to-day life we are calling laser. Okay, if one of this is 100% reflecting, that time no laser light is passing out. Okay, it have okay. So, so this is about the how laser is produced. Okay, just for your knowledge purpose, I have explained. Now coming to our main point, that is working principle of this laser beam machine. Okay, so what you have here in is the energy input. You can see in the slide. Okay, you have uh, here is the energy input in the form of, you can see in the form of heat, electricity, light, etc. And then this heat energy input is to that energy input is to the lasing medium. Okay, and that lasing medium may be your solid, it may be liquid, and then finally what you have is the energy, okay, in the form of laser beam, okay, which is useful for various activity. Okay, it can be manufacturing it can be used for manufacturing activity, it can be medical activity, it can be for other activities also. Okay, you can see that when the pointer is being used in the classroom, okay, for example, pointer is used for the classroom, but that is having some laser light, so it has various activity in different sphere of this light. Okay, and here in this laser beam machine, electrodes are kept at both the ends. Electrodes are kept at both the ends. I will explain that formed in the gas medium. Okay, that will be shown to you in the next slide also. So in this slide, you will find that electrodes are kept at both the end of the tube. Okay, then you can see this. You can see in the diagram also. Uh, the electrodes are kept at both ends. Okay, and and you will find that electrodes are kept at both ends on the of the your tube, and then electric current that will stimulate the gas or other resin medium or medium that atoms or molecules in the tube, and then there will be the feedback mechanism, okay, which is I have explained in the earlier slide that that consider of that will consider a set of parallel mirrors, okay, at the end of your tube. And one mirror is, as we know, that fully reflected, while another mirror is partially transparent, okay, which is given, which use the laser beam, okay, as uh, output, okay, which is useful for the various activities and that and whatever the light is produced, no, so that laser light is monochromatic in nature. Okay, so this is very important characteristic of laser light, okay, as in contrast to the your sun rays, okay, or sunlight. Now, uh, in this slide, you can see this is what where I have told you that it has two mirrors at the end of the tube, and there are two. Uh, views. Okay, one is known as the fullest resonated axial flow carbon dioxide laser, and you can see there are the two mirrors. Okay, so the diagram is used. 1 minute. Here you can see. Okay, so now in this slide, I have shown the diagram. You can see. Okay, so you can see the diagram. So so this is what where I told you that okay, it has two mirror at the end of the tube. Okay, so you can see we have the tube. Okay, you can see the laser tube is there. At the both end we have the two electrodes. Okay, one is cathode. You can see. Okay, so there are two electrodes. So this is known as you can see folded resonator. This is the what of the diagram I have shown now. This is called folded resonator axial flow carbon dioxide laser. And you can see here there are two mirrors are used. There are two mirrors. One is the outlet and this another mirror. Okay, one is written here highly reflecting HR mirror, and there is another mirror from which you are getting the laser beam. Okay, this turning. Now there are two tubes. You can see two tubes are there in this diagram. Okay, they are here. They have the two tubes. One is this tube, that laser beam, and another this one. Okay, down. Here you have that gas. Okay, a laser medium as a gas in both the tubes. Okay, and those protons are created, and they come and here are the two turning mirrors also used. Two turning mirrors are used. Okay, and that proton or the light get reflected from these two turning mirrors. Okay, from this when it comes from this tube, no, when it comes from this tube, it get reflected from this mirror, turning mirror, and then again reflected, and then it comes to the another tube when that where again that production of protons takes place. Okay, and after that reflecting, finally a part of that proton comes out of the output mirror here. Okay, so through this you will get the laser. Okay, and you can see you have two cathodes are here. You are clearly you can see, and these are anodes in the tube. Anodes also are there. Okay, the tube you can see anodes also there. Okay, so these are two electrodes, and this is useful for production of the laser. Okay, so that production of laser is taking place in this device, and this is very useful for comparatively high power laser. You can have the more than two tube folder also. Okay, and higher the power that you need, and more number of tube you will have to use. Okay, if you need higher power, that time you can use more number of tube. Okay, and what are the wavelength is there also that wavelength varies in a very narrow range of the spectrum. Okay, that is especially this is a specialty of this particular laser. Okay, here only I have shown the gas laser. In that I can fold it a resume axial flow laser I am showing. So this is a specialty of this particular laser. Okay, and a simple lens focuses lens focuses and it concentrates laser light in a very small diameter and high intensity. Okay, and this is known as the laser. Okay, whatever we'll get now, this is the laser. You can see also we have the laser. Okay, and also as we know that laser light is coherent, it travels in space and lower the divergence. Okay, this is a very important characteristic. Then the divergence of the laser. Okay, that high light is very small. Okay, the divergence of laser light is very small as compared to normal light. Again, use of laser in material processing it requires high power in density laser. Now there are some applications are there. Okay, that we'll see in the latter. For example, metrology applications where you do not need very high power intensity laser, density laser. A small power density lasers can do that metrology work. Okay, and the what are the you can see laser for machining operations you require 1.5 to 10 to 6 to 1.5 times to get that Weber per centimeter square laser sorry watt per centimeter square laser heat intensity. Okay, here you can see that much heat intensity is required, okay, which is very high, and as you can see the workpiece is kept very near to your focal point of the laser beam because closer it is, the more intensity of the heat is it will have and higher efficiency of that system will okay then that laser beam will have high depth of focus uh, than your normal light. You can see that on because it's at 40 point. Okay, now um, this is just the working principle laser. Now I will request all of you, uh, please draw this diagram. First, this diagram you can draw this diagram. Please draw this diagram. Okay, then I will request you to draw another diagram. Please draw first this diagram. Okay, please draw this diagram. In next lecture, I will show the another one diagram. Which is very simple. Then you can draw this also, no problem. Next lecture, once again, I will that in short, I will explain the working principle and then we'll go for that next part, the types of lasers and all these things. Please draw this diagram. Okay. Now I request all of you please write down your roll number. Write down your roll number. Very few students join. Let it be. Okay. Thank you all of you. You can leave this meeting now. No problem.